Imagine if the collective thoughts and emotions of people around the world could influence physical devices. That's the idea behind the Global Consciousness Project, or GCP, which studies whether human consciousness can subtly affect random number generators, machines designed to produce unpredictable sequences. Surprisingly, during major global events that unite millions in shared emotion, like the September 11th attacks or massive celebrations like the World Cup, RNGs sometimes show patterns that are far from random. For example, during the opening ceremony of the 2008 Beijing Olympics, as billions watched in awe, researchers observed slight but statistically significant shifts in RNG outputs. It's as if the shared focus and emotion of the global audience rippled through reality itself, like synchronized clapping echoing through an arena. The GCP invites us to wonder, is consciousness just in our heads, or does it have the power to subtly influence the physical world? While skeptics argue these effects could be mere coincidences, the idea remains fascinating, a potential hint of a mysterious connection between our minds and the universe. Imagine a massive orchestra where human thoughts and emotions might play an invisible, yet measurable role in shaping the symphony of existence.
Psychophysical duality refers to the philosophical and scientific exploration of the relationship between the mind, consciousness, and matter, physical reality. While traditionally considered separate domains, emerging research suggests potential interactions between the two. This concept has gained attention in projects like the Global Consciousness Project, GCP, which investigates whether human consciousness can influence physical systems, such as random number generators, RNGs. By probing the interplay between mental intention and physical systems, the GCP seeks to understand whether collective human consciousness can create measurable effects in the physical world. Example: during globally significant events, such as major celebrations or disasters, the GCP observed deviations in RNG outputs, suggesting a link between mass consciousness and physical randomness. Analogy: psychophysical duality is like trying to measure the ripple effect of a thought on a still pond, where the mind represents the stone and reality is the water. The GCP, initiated at Princeton University, monitors a network of random number generators, RNGs, worldwide to study the influence of human consciousness on randomness. RNGs produce sequences of numbers that are statistically random under normal conditions. However, during globally significant events, the GCP hypothesizes that the collective focus or emotion of human consciousness might alter these patterns. Data from the GCP's RNG network is analyzed using rigorous statistical methods to identify deviations from randomness that correlate with events of collective emotional or psychological impact. Example: the GCP recorded significant deviations in RNG outputs during the 9/11 attacks and other major global events, suggesting an influence of collective human consciousness. Analogy: the GCP is like a global barometer, measuring the subtle impact of shared human emotions on the physical world. Random number generators are devices that produce sequences of numbers without any predictable pattern. Quantum RNGs, often used in experiments like the GCP, rely on inherent quantum uncertainties, making their outputs truly random under normal conditions. The hypothesis underlying the GCP is that collective human consciousness, particularly during heightened emotional states, could somehow influence the behavior of these quantum systems, leading to measurable deviations from expected randomness. Quantum RNGs based on photon behavior are considered ideal for detecting consciousness-related influences due to their sensitivity to subtle perturbations. Analogy: RNGs in the GCP are like ultra-sensitive seismographs, detecting tremors in the fabric of reality caused by collective human consciousness. Over 2 decades, the GCP has amassed a dataset correlating RNG outputs with major global events, including natural disasters, political upheavals, and cultural celebrations. Statistical analyses often show small but consistent deviations from randomness during these events, which cannot be explained by conventional physical processes. While the results are controversial, proponents argue that the patterns observed suggest a subtle but real interaction between consciousness and physical systems. Critics, however, highlight the challenges of interpreting such data and the possibility of statistical artifacts. Example: during the 2008 Beijing Olympics opening ceremony, GCP RNGs showed statistically significant deviations, coinciding with the global focus on the event. Analogy: the GCP's findings are like finding faint but consistent footprints on a path, suggesting an unseen traveler consciousness has passed by. Theoretical explanations for consciousness-matter interaction. Scientific explanation. Several theories attempt to explain how consciousness might influence physical systems. Quantum mechanics. Some interpretations suggest that consciousness plays a role in collapsing quantum wave functions, which could influence RNGs. Global field of consciousness. This hypothesis posits that human minds are interconnected, creating a collective field that interacts with physical reality. Emergent phenomena. Consciousness may emerge as a non-local property of complex systems, capable of influencing physical processes in ways not yet understood. These theories remain speculative but provide frameworks for exploring the interaction between mind and matter. Example: the concept of quantum entanglement is often cited as a possible mechanism for non-local interactions between consciousness and physical systems. Analogy: theoretical explanations are like trying to map uncharted territory, connecting the dots between known science and the mysteries of consciousness. The GCP has faced criticism from the scientific community, primarily due to the difficulty of replicating results, the small effect sizes, and the lack of a clear mechanism linking consciousness to physical systems. Statistical artifacts, confirmation bias, and the subjective selection of events are among the challenges in interpreting GCP data. Skeptics argue that the observed deviations could result from random fluctuations rather than meaningful effects of consciousness. Rigorous controls and independent replication are necessary to validate the findings. Example: critics often highlight the lack of a consistent pattern in RNG deviations across different types of global events, questioning the robustness of the GCP's conclusions. Analogy: criticisms of the GCP are like trying to determine whether a shadow is cast by an object or a trick of the light. It's hard to discern what's real. Research into psychophysical duality has potential applications in fields such as medicine, psychology, and technology. For instance, understanding the link between consciousness and matter could lead to breakthroughs in mind-machine interfaces, alternative healing methods, and even quantum computing. In addition, projects like the GCP inspire interdisciplinary collaboration, bridging gaps between neuroscience, quantum physics, and philosophy. Example: advances in biofeedback technologies, which allow individuals to influence physical systems through focused intention, are inspired by concepts similar to those explored in the GCP. Analogy: applications of psychophysical research are like opening a door to a new dimension of science, where mind and matter converge. Future research aims to refine methodologies for studying consciousness-matter interactions, such as integrating advanced quantum sensors, machine learning for pattern recognition, and larger, more diverse data sets. Expanding studies to include varying cultural, psychological, and environmental factors could provide deeper insights into how consciousness interacts with physical systems. There is also growing interest in exploring whether collective consciousness can influence complex systems beyond RNGs, such as weather patterns or biological processes. Example: ongoing experiments aim to use quantum computers to test consciousness-related effects at even finer scales, potentially uncovering new principles of psychophysical interactions. Analogy: future research in this field is like building a telescope to explore a hidden universe, uncovering connections between mind and matter.